Okay. ANOVA is short form for analysis of variance. It is the same like t-test, but t-test can only compare between two groups. So ANOVA can compare more than two groups. Okay. For example, you want to compare between Malay, Chinese, Indian, and others. Okay. What do you want to compare? Who is fatter? Malay, Chinese, Indian, or others? We did a study in Kelantan. The smallest are the Siamese girls, followed by the Malay girls. Sorry to say, the fattest girl are the Chinese. Doctor, how about Indians? There are no Indians in Kelantan. Okay, so let's look at here. Example, you want to compare cholesterol level between bus driver, bus conductor, and taxi driver. And that's when you use ANOVA. Or you have to compare the blood pressure of the Malay, Chinese, Indian, and others. Who got the highest blood BP? Indians. Followed by the Malays, then Chinese. So, the data must be normally distributed, equal variances. Okay, they are independent of each other. Doesn't matter. Same thing like that. So some examples that you can do. Okay, who got the biggest baby? Housewife, office worker, or field worker? Why? Because they watch telenovela every day. Those working in the fields, those working in they tend to have, why? Because I think because they got bigger muscles. They got to carry heavy things. Okay, but it is not significant. It is not significant statistically. Because you see here, the housewife, you got one housewife here, sitting watching telenovela every day. The baby come out 4.72 kilogram. I wonder it come out through the door or come out through the window. So why we don't use it for exam? Because it is mission impossible to calculate manually. Okay. Example given here, we have 45 samples. We got 3 machine 1, machine 2, machine 3. Then we want to calculate which one is the fastest. So first we have to calculate the grand mean. Based on the grand mean, we compare against the group mean. Okay. This grand mean compared against the group mean is known as SSB. This SSB not scheme saran baru, but it means the sum of squares between groups. So basically the value of the mean of the group minus the mean of the grand mean, so on and so forth. You do it again and again for all the 3 groups. The answer here is the sum of squares between groups. Okay. So that is tough already. Why tough already? Because it looks like variance, but it is not really variance. Okay. So how do we do it? It's like this. First we get the grand mean. Based on the grand mean, you get the mean of the machine 1, 24.93. So then you 24.93 minus 22.71. Then mean of machine 2, 22.61 minus 22.71. Then you do it again 3 times. Then the squared values you combine, it becomes the SSB. 141.492. Are you done? Not yet. Remember, you have the difference, but now you have to get the standard deviation, but this time for the ANOVA. So the standard deviation for ANOVA, how to get? You have to get by doing MSE, mean square error. To get the mean square error is horrible. Why horrible? You have to get the difference of each observation against their group mean. So that is the group mean. You have to get the difference of every single one against the group mean. Die lah like this. Okay. So how many calculations you have to do? You have to do this much calculation. I give you 2 hours to calculate, so you cannot finish one. Guarantee cannot answer one. So that's why, do I have the question? Yes, I have the question. But I reserve that question for a batch where I want to fail everybody. Okay, and this is the formula for the MSE. Okay. Why it is so bad? Because not only after that you do all this, you get the mean square error. From the mean square error, you have to put into a formula to get the F value. Okay. Next is the F value. So this is the formula to get the F value. From this F value, you will convert to become P value. So the one that will save you all, that you will see your table, the table formula don't have the ANOVA F value conversion. So that's why I can never ask this for exam. So, do I have the table? Yes. But I'm not going to give it to you because I don't want to waste paper. Okay. So we have to convert the F value to become the P value. Okay. So this is the F. So the P value is somewhere very, very far away. Why? Because the F is 89. So it is very, very far away. Don't have. Okay. So where is the table? The table looks like this. Okay. Again, I say you don't have the table. Only I have the table. Because I'm not going to give it for exam. Okay. And with that, you convert the F value to become the P value. Okay. So what is the P value? 0.000000000000008. Okay, doctor. So what are we supposed to know? The only thing you are supposed to know is this. You are only supposed to understand only two things. What is the F value? What is the P value? You have only to understand that the P value come from the F. The F come from the mean square and the sum of square. Itu saja. Okay. So the only thing you have to know is like this. Okay, sum of square mana? Berapa? What is the value of sum of square? You got the notes, right? 141. What is the mean square error? 0.795. Okay. What is the F value? 89. Okay. What is the P value? Less than 0.01. That's it. So that is the only thing that you're supposed to know about ANOVA.